Hello everyone, my name is Pedram and I'm a professor in Data Analytics Department at Utah State University. I teach machine learning, deep learning, and deep forecasting, and I'm also a CFA charter holder. In this video, I want to see if we can predict stock market prices using univariate time series. More specifically, we want to see if, for example, something like this, the price of Microsoft is predictable using classical econometric time series model like ETS, ARIMA, theta, you name it, or even the more advanced machine learning approaches like boosting algorithms is able to predict these stock market prices, right? And so we're going to do it in PyCaret, and because of that, I'm going to only cover the classical time series and machine learning models. Later on, in the deep learning course and the deep forecasting course, I will cover and see how deep learning models are able to predict stock market prices. Okay, so if you're curious to know the answer, and the short answer is no. So the prices are, this is actually financial time series, especially stock prices, are really hard to predict. Because of multiple reasons. So we talked about the challenges of doing time series machine learning in the theory part of the deep learning and deep forecasting course. I'm going to put the link below in the description. And but in general, they have some properties. Financial time series have some properties that makes it super complicated to predict. Can we predict stock market returns? The answer is it's possible. We can do a lot better than flipping a coin, but the problem is that even if you can tell if the market is going to go up or down, if you can predict the returns, so this is what we actually are able to do. The problem is that you only can say something about the sign of the bet, right? You can say buy or sell. You cannot say much about the size of the bet, and usually a couple of big losses is going to wipe out all the profit of the portfolio. Okay, so why am I doing this? My point is not to get you disappointed when it comes to stock trading. On the other hand, I don't want to give you high hopes that this is a simple problem. It is not. Are there people out there making money using machine learning and deep learning for stock price prediction? The answer is yes. Are there many people? The answer is absolutely no, right? So basically, my short answer to you is that I think it is good for you to invest learning these things. And maybe sometimes you want to join a hedge fund company or an investment bank, or you have more resources. You have access to more resources in terms of high frequency trading, the proximity to exchange, and so many other stuff, right? If you have more resources, then you can go play these games in a higher level league, right? But as a retail investor, I personally think it is not necessarily worth your time or effort to try to just outbid the benchmark or outbid the market, right? Why am I doing a stock market price prediction? Because so many people are interested in that, and I was thinking, there are so many details when it comes to predicting time series. So why not talking about the most difficult one, which is the stock price prediction? So without further ado, let's see where we can find the materials and the background and theory if you need a refresher, and we will jump into doing things in PyCaret. Okay, in terms of theory, so you can go to either the deep learning course or the deep forecasting course. Either of them will do it. So for example, I go to the deep learning course. There is this lectures and codes. By the time you're watching it, probably there's going to be 9 or 10 modules here. You go to machine learning review, and here are the slides, right? So when I talk about machine learning and boosting review, so there's this PDF. At the third part of this PDF, I talk about challenges of time series machine learning. Okay, so this is basically where this slide is coming from. Okay. So again, I have done a theory video, so make sure you can watch it on the right channel, playlist on this channel. And then I'm going to quick review, tell you what we're going to cover in this one. This is a PyCaret one. So we know that when it comes to time series, there are some challenges, especially stationarity, seasonality, limited data, or the time dependencies. Maybe this is the most important one, right? So the cross-validation is different, the bootstrapping is different. So again, I'm not going to go over these things, but I just want to show you that there are different methods and just quickly show you the laundry list. So for example, when it comes to cross-validation, we know we can do paired k-fold cross-validation. We can do walk forward using rolling or expanding windows. We can use combinatorial pairs cross-validation. In PyCaret, we can only apply this one, the second one, walk forward, rolling or expanding window. Then when it comes to bootstrapping, there are different methods we can do, for example, parametric or non-parametric. For non-parametric, we can do moving block bootstrap or circular bootstrap or stationary bootstrap. How do we do things in PyCaret? None of them. We simply can turn on or turn off the bootstrap thing to make sure that we have considered both of them, but the bootstrap is done traditionally, okay? But the good thing is that when you're using machine learning with PyCaret, the data is already detrended and deseasonal, so it's most probably stationary. So we should be less worried about this shuffling, the idea of shuffling the data. But at the same time, for the models that are using bootstrapping like random forest, we can easily switch off that bootstrap to make sure that we are not shuffling the data. Either way, we're going to see the output. Okay, and one last thing before going to the Python part, I want to make sure that how we prepare the data for time series machine learning, right? So basically we have to convert time series problem into machine learning, and this is model agnostic. So it means that once you have done this step, you can apply any machine learning model you wish. You can go from simple linear regression to most sophisticated, let's say XGBoost or CatBoost or LightGBM, you name it, right? So, but this step is actually that this is necessary for us to prepare the data. And remember, I'm doing univariate time series regression, right? This is not multivariate. So our feature space, these are just y variables, a lag version of y's, and this is our target variable. So what do? We have a time series, y goes from y1 to y thousands or millions or whatever, right? So these are your stock prices, okay? Let's say day 1 through day 8. Then I'm gonna use this as feature number 1. This is my x1. The x2 is simply the lag version of this. So this is y2 through y9. x3 is lag version of this. Lag 2, y3 to y10, and x4, lag 4, right? So the lag 3, sorry. So it goes from day 4 to day 11. So imagine I'm gonna use a window of 3 lags, right? So the original time series, x1, x2, x3, and x4. You can expand it. You can expand it to as many numbers as you wish, right? You can say my feature space should have, let's say, 21 dimension. Basically, if you're looking at the stock market daily prices, you want to see, okay, let's use the past 21 days, the past month, 21 trading days, to make a prediction for tomorrow, right? So that can be, you can go all the way to the day 21 and make a prediction for day 22, right? What we're doing here, I'm using a window size of 4, and then basically it means that you're using the past 4 observations to make a prediction for tomorrow, right? So this is for day 5. So this is one step ahead forecast, right? Some of the machine learning models are capable to generate multiple step ahead at one time, so we call it multi-output predictions. So for example, at the same time, having y1 through y4, some of the models are able to generate y5, y6, y7, y8, and etc., right? In deep learning, we're going to, for example, use LSTM, and LSTM is perfectly capable to do something like that, right? But what we are doing in PyCaret, what is available in PyCaret, we do one step ahead forecast, and then we're going to extrapolate it into future. We can make some multi-step ahead forecast, right? So we don't do multi-output forecast at the same time. All right, hopefully that makes sense, but that's probably the main thing you should know before going to the Python. So, and now I have simply my x's, I have my target variable y, and I can apply any machine learning, right? So I can go ahead and do train test split, and after splitting, I pass that train set to train the model and to look at the cross validation and all the other things that we've discussed in the machine learning part. All right, so now let's go to the Python part. I go back to the folder. So that was the theory part where you can find it. For the PyCaret, I put it in this repository. It's also available in deep learning and deep forecasting as well, but here it's platforms and tools. You go there, there's this PyCaret, and then I add it here. So this is the notebook that we're going to work on. So it's called Predicting Stock Price Using PyCaret. Okay, so let's go ahead and open it. And you can either run it on a Google Colab by clicking on this link, or you can run it on your local computer. I'm going to run it on my local computer. So if you want to do it on Colab, make sure you uncomment this one and then run this line, right? So this is going to go ahead and install the PyCaret 3.0 version. That's why we have dash dash. So if you do dash dash pre, it's going to install the 3.0 version. By the time that you're watching this, maybe they're going to get rid of this flag. So if you do pip install PyCaret full, you're going to get 3.0, right? But just make sure you read the documentation of PyCaret when it comes to installation and you know what version you should install. This is PyCaret 3.0 as of February 2023, and we're installing the PyCaret full version. Full, basically, it contains more models, and models like XGBoost, like CatBoost, and LightGBM, which are not, I think LightGBM by default is in PyCaret, but XGBoost and CatBoost are not. So I'm going to work with the full version. Once you run this is going to take 5 to 10 minutes depending on the speed, so that's why I'm going to run it on my local computer. What we're going to cover is basically talking about this idea of stock market price prediction. I'm going to show you the data. So the data is also available on my GitHub repository in the data folder. So this is coming from the deep forecasting repository, but again, in the data folder, there is this file called Y Finance, which I generated from Yahoo Finance. And we have a bunch of let's say ETFs or stocks. We specifically want to work with the Apple price today, and we look at the adjusted close, and then it goes all the way from 2018 January to end of December 2022. Okay, and yeah, that's pretty much it. So we will talk about time series cross validation, bootstrapping with PyCaret, how to predict model, how to finalize a model, and then make a conclusion. Can we really predict stock market price as it is using PyCaret? All right, so I'm going to go ahead and open this on my local computer and take it from there. Okay, so let me open my VScode. So this is the same file, and I'm in the right environment on my local computer. I call it PyCaret 3. So this is the kernel, and I have already installed it. I really want you to have these documentations open and handy in front of you, because we work with kind of these automated packages like PyCaret, let's say low code packages like PyCaret. It is really important to understand how you can find the source code for the functions, right? Because usually you're going to run one line of code, and sometimes you want to change some parameters, the quarks of the model, and you're wondering where you can find it. The best way is to look into the source code, right? So I'm going to open PyCaret documentation. Let's open all of them. Sktime. This is a time series package built on the bunch of good packages in Python, including scikit-learn for the machine learning part. And PyCaret is built on top of this one and many other packages. And then last thing, I'm going to open this PyCaret model container folder. So let me show you where you can find it. This is in the PyCaret GitHub repository, the PyCaret itself. And that's the link, but you can always Google for it. Search for PyCaret GitHub, and then This is PyCaret GitHub repository. This is the main repository. I don't know why it's taking a little long, but yeah, there is this. Yeah, so this is a repository of PyCaret itself. This is the official repository. You go to the PyCaret folder. This is a repository, and then go to PyCaret. There is this container folder. This is the containers. This is the model container, and you can go to the models. You can get access to these are the main categories in PyCaret, right? You can do regression, you can do clustering, you can do time series regression, classification, anomaly detection, and NLP. Okay, so let's do time series regression. So this is a Python source code, right? It means that all the models that are available in PyCaret, here's the class. So for example, you want to do, I don't know, linear or random forest, right? You search for random forest, and then you find that, okay, the random forest, the name, here's a class, you know, random forest. CDS stands for, I think, conditionally deseasonalized, and then detrended. So basically, you want to make sure that the time series that you're passing is stationary. We can do stationary tests and etc. But basically, here's where you can find a class, right? And you will see that this class is directly coming from scikit-learn, the ensemble module, you know, random forest regressor, right? And then we can play around with the properties. So these are the quarks that you can pass to the model that you're creating in PyCaret, right? So for example, you can change the deseasonality model, you can change the degree, you can change the window length. So this is important, right? So this is what we're talking about here. How many X's you want to have to make a prediction for the next observation, right? And so you can play around with all of these things, and these are the tuning, let's say the tuning parameters. You can look at the bootstrap. So for example, the regressor bootstrap, it can be on or off. As I said, the PyCaret is not equipped with more advanced bootstrapping methods like, you know, these ones, you know, moving block bootstrap, circular bootstrap, stationary bootstrap. You can do none of these things. If you want to do, you have to do it manually from scratch. I'm going to show you how to do it, but just be aware these are not available. So when you're doing PyCaret regression in time series, you have to make sure that the algorithm is trying these ones. You know, basically, if your dataset is, especially if it is not stationary, you must switch this to false. Yeah, so this is where you can find all the details and how we can play around with the source code. Hopefully that was helpful. Okay, now, and let me show you the other two. So this one is for PyCaret itself. You go to the time series. So this is official PyCaret documentation. And again, you can set up the environment or experiment, they call it. You can create a model, compare the models that you have, run a horse race between all the models available in PyCaret for regression, including classical time series regression and machine learning. And as I said, for the deep learning, we are going to do it differently. We're going to use TensorFlow and sometimes some other packages in Python. And you can tune the model. We are going to do lots of visualizations for EDA of the data. We are going to make some predictions and finalize the model. Okay. So hopefully you have watched the basics of PyCaret videos on my channel, or you're familiar with the basic stuff. But I try to do this this notebook, and try to do this video as a standalone. So if you have zero background, you should be able to follow. All right. So once you've installed it on your local computer, you are gonna quickly check the version of it. So my version is 3.0. Again, by the time you're watching it, it might be different, but this 3.0 is the one that we're gonna use because it enables us to work with different experiments. So this is new compared to version 2. All right, for visualizations, actually, yeah, we're gonna do some time series pre-processing, so that's why we're gonna use pandas and NumPy. Matplotlib, we are just going to use it once to just show you the historical price. We could ignore this part because PyCaret is, we can do simply use the PyCaret visualization functions. All right, again, here's the data. Make sure your index column is 0 because the index 0 is the date, and the header is 0 and 1 because this is kind of the data set when you're downloading from Yahoo Finance. You see two rows for headers. You know, here, row number 1, it's saving the adjusted close, open, high, low, and volume. And the second row is holding basically your stocks and ETFs, right? So make sure the header is 0, 1. If you import it correctly, you should see something like this. We are going to look at the index. The index, if you're importing anything from a CSV file, because CSV doesn't have memory, it's a flat file, so the type is not reserved, the type of the random variables. So your date variable is going to be simply index. We have to change it if you want to pass it to PyCaret, right? So we have to change it to period. We can do it to change it to date time, you know, regular date time, but there's some functionality in PyCaret that requires you to have periods, right? So that's why we're going to do it that way. So I'm going to say change the index of this stocks data frame that you created. First change it to date time, and then change it to period, and this is business day. And now if I look at the index, is period index going from January 2nd, 2018 to December 30th, 2022. There's this one little caveat that comes with PyCaret. I don't want to call it caveat, but you should be careful, right? These are business days, right? These are not trading days. So because we know that the stock market is closed and it doesn't include holidays, right? So for example, we have 1,259 days. Now, if I look at the range of, we're gonna look at it in a second. If I look at the range of available days between, let's say January 2018 to December 2023, it's, I think, 50 something days more, you know, including Christmas, you know, Thanksgiving, you name it, right? The holidays. So we should fix that. Otherwise, the PyCaret is gonna complain. Other time series forecasting packages like sktime or I don't know, some other ones will not complain, but PyCaret will. So this is something you need to fix it. Okay, so for this exercise, we're going to look at Apple stock close price. We want to work with unadjusted close price because, well, you can't, here we could use adjusted close, but if you're using multiple variable time series, if you want to, for example, add volume, open, low, high, and the close, you have to make sure that you put close, not adjusted close. But because open, low, high are not adjusted, or if you have access to the adjusted versions, which it's not available in Yahoo Finance, I believe, you have to do it manually. Okay, so be careful. So that's why I'm gonna stick with the close, and yeah, let's run this. This is what we want to use, right? We can quickly look at the plot. This is Apple's stock price from 2018 to end of 2022. Okay, and this is what I was talking about. The index of this data frame is period index, business days, and length is 1259. If I go ahead and create an object, call it IDX, this is index, right? And say using from pandas, say that give me a period range between day 1 and day T, capital T, last day of this data frame, and show you the index. This is exact same thing. It's period index, but look at the length. The length is 1304, right? So it's different. There are 65-ish days different, 45-ish days difference between these two time frames, right? Time steps. You can look at those days, you know, by using this symmetric difference method off of the index. So if I do that, I see that, okay, no surprise. So these are holidays, right? So 26th, 24th, and etc. So these are the way, at least the days that were not available from Yahoo Finance, right? So the market was closed. So what should we do? Again, this is only PyCaret specific, right? If you're working with other packages for time series prediction, that's not the case. In PyCaret, you should fix this problem. So I'm going to go ahead and say, you know what, this data frame that I have, let's go ahead and re-index. And I'm going to use this IDX, the new one that I just created. But the problem is that it has 45-ish. Let me do the math when I'm using this number. So 1259, so 45. So 45 days different, right? So I'm going to fill those different days with NA, right? And I'm going to show you the tail of this data frame. Because 26th of December is there, I'm going to show you that, okay, this is one of those NAs. You can look at the past 10 days, right? So this is NA. Now, how should we fix this? We are going to use fill forward method for filling NAs because the 26th of December, the price that we see for the market is 131.86, right? So I'm going to fill this one forward to this NA, right? So let's go ahead and do that and pay attention to 26. So 26 is 131.86. So this is what we see in reality, right? In terms of what are the prices at each specific day. I can plot it again. And now the 45 missing days are imitated by the forward filling method. Okay. All right, so that was the first part, right? So we have the data. I think this is one of the most important part when it comes to time series analysis in general. You have to get a good grasp of the index of the data frame and make sure it's compatible with whatever package you're working with. I'm gonna from PyCaret time series import everything. And so there are a couple of things I want to use, right? So how do we handle cross-validation with PyCaret? So this is something that we're going to look into in the setup. So let me skip these cells. I'm going to come back to them and explain why am I using it here. But when you're creating an experiment, we say this is a time series forecasting experiment, and you have to set up, right? So the setup is pass the data, pass the target variable, which is Apple here. This is coverage, confidence interval coverage for the models that are generating the confidence intervals. Fold the strategy, this is important, right? So let's go to the setup documentation and see what we can see there. So this is PyCaret documentation, go to setup, and if you scroll down, there is this feature that you can change. It's fold strategy. Let me actually search for it. Fold strategy, right? So right now, what is available in time series in PyCaret is these ones: expanding, rolling, and sliding. And actually, this rolling and expanding are pretty much the same. So we can do sliding window, we can do expanding window, and this is what we had to walk forward, right? This is expanding window, this is a rolling window. You can go ahead and adjust this using a sktime package, right? So again, you can go ahead, this is perfectly fine if you just use rolling window and then specify the number of folds you want to have, right? So I can say, let me show you either way. Let me copy this one and show you the default version and the one that I use from sktime. I want you to learn it both ways. So I'm gonna call it experience, just for the sake we don't mix these experiments. I'm going to call it experiment 1 and then say df, and now I can go ahead and change the fold strategy, and I use one of the default ones that comes with the PyCaret. So the fold is, let's use a sliding, and of course for stock we are going to use sliding because this is important. Because if I use expanding and you're looking at Apple from 2018 to 2022, and think about the longer term horizons, right? Apple 10 years ago is not the same company as of today. So it doesn't make much sense to use all the information going back from 10 years ago because of structural changes, the company's status changed and so many things, right? Tesla today is so many different than Tesla, is different from Tesla even 5 years ago, right? So for that reason, we're going to use rolling windows. We're going to say, for example, use the past 6 months to make a prediction for next month. Okay, so this is what we do. Maybe the past 6 months is a better one, and this is exactly what I'm going to do, right? So there are two ways to do that. One, doing this way, sliding. If I do sliding, it's not that flexible. I have to come up with a number of folds myself, right? So let me show it to you. Okay, so we can go ahead and do sliding, and as I said, it's not that flexible, so we have to specify the number of folds. For example, I don't know, this is a large data set, right? 1300, and let's say 10 folds. We definitely need more folds if you want to have less overlap, but just for the sake of discussion, let's keep it simple, 10. And then one other thing that I need to pass, if you're setting up your experiment like this, you have to pass the forecasting horizon, right? So let's go ahead and pass the forecasting horizon. Let's say we want to make a prediction for next trading month, 22 days, right? Yeah, we can run this experiment, and then I'm going to go ahead and show you the cross-validation plot for this experiment, okay? And then we can say from this experiment 1, go ahead and plot the cross-validation. So this is what I already ran because it's going to take a little long because again the data set is not as small, and plotting the cross-validation usually takes time. So this is your 10 folds, right? And here you have 10 folds and going from 0 to 9 and for cross-validation. And this is literally our rolling window walk forward cross-validation. we are using, because we divided by 10, we are using this amount of train set to make a prediction for the next month, right? So maybe you want to be more flexible. Maybe you want to say that, you know what, just use the past 6 months, make a prediction for next month, right? And you want to make sure there's a gap between these things, because remember, this is the simplest way you can do cross-validation for time series. There is no purging, there is no embargoing, we're not adding these paths before and after the train and test set, right? So maybe we should make a little bit of gap between these windows, and this is what I want to do using sktime, right? So if I go back to the documentation for PyCaret, when you go to the fold strategy, let's find it one more time. So let's go back. So this is the fold strategy, right? So let me see, I have to go to the setup and then search for fold strategy. I want to find the right one. Sorry, let's find it manually. So where is this fold strategy? Well, okay, so let's see. Yeah, fold and fold strategy. You see that again, expanding, rolling, sliding, you can also pass a sktime compatible cross-validation objects such as a sliding window splitter or expanding window splitter. So this is what we want to do. So I'm going to open up the sliding window splitter documentation from sktime, right? So I can go ahead and search it directly here and then find it. Or you can just find the link here. No, I think I added up there. Here's the link, right? So let me see. Yeah, sliding window splitter. And that's it. There are different splitters that you can use. This is the sliding window, right? So you can do single window splitter, expanding window splitter, temporal train test split, and this one. So this is the one that we're using. So I have to literally pass this class to my fold strategy in PyCaret, set the forecasting horizon to a number. Again, because this is, we are doing this from sktime, so it should be an array. So say, for example, make a forecast from day 1 to day 22, and this is what we're gonna do. Okay, and then window length. So at the end of the day, you will see something like this, right? So this is what we had. And what are the parameters? Window length. This is the length of the window. For example, 1, 2, 3, 4, 5. So I'm gonna pass 6 months. Let's say 130 days. Step length. Your next fold, your next iteration, you want to start from where? If the step is by default, it's going to be 1, so it's going to move 1 step ahead and then make these train. We're going to pass 6 months because we want to make fewer overlap. Again, our data set is large enough, and we want to visualize a smaller number of folds. So that's why I'm going to say, okay, 6 months for window, 6 months for step length, and we don't need to deal with the initial window. We'll start from January 1st, and then we take it all the way to the end of it, right? So this is more flexible. And here, I just want to show you how it looks. I copy this one and paste it to the notebook. So if you look at the notebook, so here, from sktime, forecasting, model selection, sliding window splitter, let's import that one. And now this is what I directly copied from the documentation. So I just want to show you something. Say, okay, forecasting horizon, as I said, it's a range between 1 and, so this is going to be between 1 and 3 is 1 and 2, right? So, and then window 3, and then step length 1. So imagine we have a time series, numbers between 0 and 10, right? 0 and 9 actually, this is Python, right? And then we want to see how we can split stuff. If I run this, you will see that we are using a window length of 3, 1 to 3. We are making prediction for 2 steps ahead. And then step length is 1. So it means that I go from 0, 1, 2. The next one is 1, 2, 3. The next one is 2, 3, 4. The next one is 3, 4, 5. And I'm moving these windows 1 step. If I change it to 2 steps, you'll see what happened. I go from 0, 1, 2. Again, 2 steps. 1 step, 2 step. I start from 2. 1 step, 2 step, I start from 4, okay? And then same story for the range. So for example, I can say, let's make the steps 1, yep, and then let's say window length is 5, right? So you get the idea. Hopefully it makes sense. So this is what we are gonna do. So I'm gonna create another environment. So we don't need this experiment anymore. So let's create another experiment number 2, or actually let's call it experiment. So this is a difference. I'm saying fold strategy now is a class from sktime. It's called sliding window splitter. The forecasting horizon, from 1 to 22, this is 22 trading days. Window length 130, roughly 6 months. Step length 130, again roughly 6 months. And once you're doing it this way, you do not need to pass the forecasting horizon separately anymore. If you do, it's not going to complain, but it will override this one on this one. So for example, if I say forecasting horizon 10, it's going to go ahead and pick forecasting horizon 22 for me, because this is going to be overriding this. Let me actually show it to you. So even though I pass the FH here, forecasting horizon 10, now the holdout period is 22. So as you can see, this is prior to this one. So I'm going to go ahead and erase it. All right. So this is our experiment. And now we can do some plots. So plotting is going to take time. I have run this before, so I just want you to just follow along the code. If you press on any of, so this is going to be fast. So for example, this plot is fast, but this plot took almost a couple of, I don't know, maybe 5 minutes. But at the end of the day, you should see something like this, right? Now we're using 6 months to make a prediction for 1 month, maybe the first half of 2018, second half of 2018, first half of 2019, second half of 2019, and etc. Right? So maybe if you want to go with 9 folds, and this is what you get, right? And another thing I wanted to say, this is actually, I'm not quite 100% sure, so that's why I said as a side note, I tried to read different source codes and from PyCaret, but I couldn't figure it out myself, and I don't know why it's the case. So let me show you what I mean. If you go to the PyCaret documentation, surprisingly, when you go to the regression, not time series, when you go to the regression, and when you go to the setup for regression, the folding strategies are a lot more flexible. So if you go down to fold strategy, let's say, I don't know why I'm having a hard time finding this. Yeah, folding strategy. Okay. So here for regression, this is not time series, this is regression. You can do k-fold, you can do group k-fold, you can do, so I get this part, we don't need k-fold or group k-fold for time series, but there is this nice time series folding strategy available here for the regression, but not for the time series. So this is a little surprising to me. And this is good because this comes from scikit-learn package. And actually, I like this time series folding strategy from scikit-learn because it enables you to assign to assign some gaps between the windows. Let me see if I have the link here for you, or otherwise we can search it. Yeah, let's search it. The link is not here, so I'm going to say time series split from scikit-learn. So I was expecting when I run this, it doesn't give me an error, but it does. So it said it's not compatible. Actually, you can see that for yours. So I was thinking that, okay, let's go ahead and do this time series split for fold strategy. This is a scikit-learn thing. It's not a sktime. And then we can do number of splits. We can do max train. We can do gap. So this is what I was hoping we could get, because this gap is effectively working as a purging or embargoing. We don't have that luxury in the PyCaret package. And when I run this, it complains, right? It says that time series split has no attribute FH. Basically, it's not compatible with that. I tried to troubleshoot this, I couldn't. And if you found a get around, just let me know in the comment section below, because this is a cool feature, right? And basically, it's available in scikit-learn. So I can copy the entire thing and show you where you can find more. So yeah, this is model selection, and actually the gap thing is a new, well, relatively new. It's been there for the past year, I guess. But if your scikit-learn version is older, you're gonna get an error because it says that the gap is not defined. So you have to make sure that your version of scikit-learn is newer than 0.24. So yeah, that's it. This is a nice time series splitter, which surprisingly, I don't know what I'm missing, but surprisingly, at least surprisingly to me, it's not available with PyCaret. So yeah, we're gonna leave it like this. Just if you want to do fancier splitting, like purge, combinatorial purge, you have to, at least as of now, you have to code it from scratch for yourself. Okay. For general time series, let's say you want to predict demand. You want to predict airline passengers. You want to predict, let's say, Amazon sales or Walmart sales. So these are relatively more predictable time series. These are, I want to call them, more well-behaved compared to stock market. For those ones, in practice, I didn't find a big difference between using different cross-validation methods, honestly. When it makes a big difference is if you want to build a trading strategy in the stock market, it's just going to make a big difference. Because when it comes to trading strategies, if you don't do the right cross-validation, you might get a fake good performance in the cross-validation set or even in a test set. And when you apply that trading strategy in real world, it's going to lose money. So that's why, again, the source for this discussion is there's this book called Advances in Financial Time Series by Marcus Lopez de Prado. He covers all the details why the backtesting is important to be done correctly, basically using purge combinatorial cross-validation. Again, I talked about the theory of this one in the theory lecture. Check it out if you're interested. Okay, so let's move on. And now, next step, you can go ahead. Actually, allow me to just run through the code, because if I want to just show you the output, because if I want to run it, it's going to take some time. So I'm going to go ahead and compare models. I can sort them by RMSE or R-squared or whatever. At the end of the day, we are running this horse race between classical time series regression models and machine learning ones. And it seems that our naive forecaster, this is a simple random walk without drift. The naive forecaster is the first one, at least based on RMSE and mean absolute error. Based on R-square, theta is doing okay. These are not tuned, right? We're going to go ahead and tune a bunch of them and see which one is better. And where is our machine learning one? So for example, ETS is here, AREMA is here. The machine learning ones, all of them are labeled with CDS DT. This is important, guys. Basically, it means that, for example, if you're using linear regression or elastic net or random forest or gradient boosting, all of them are conditionally deseasonal and detrended. So basically, you want to make sure that the dataset is stationary. And actually, this is good, because I'm less concerned with the bootstrapping thing, right? Because bootstrapping was also a challenge for machine learning. But if the data set is transformed, detrended, deseasonal, basically made stationary, then I'm less concerned. Okay. But again, if you want to do it properly, you have to do these things from scratch. I want to show you how to do that. Okay. So yeah. Predicting stock market price, not so promising so far, right? Your random forest is doing a better job. And by the way, look at the R-score, is ridiculously low. It's negative. It means that a simple average is outbidding all these models, right? Okay, and these are cross-validated, right? So you're using 6 months to make your predictions for next month. Okay, so bootstrapping with PyCaret, again, there's not much available with for bootstrapping in PyCaret, at least as of now, or as far as I know. But if you want to do it correctly, you can use this awesome package in Python. It's called Arch. Let me show you. It's written by Kevin Shepard. This is a very awesome package. And let me actually show you where you can find it. So here's the Arch package. You can go to the bootstrapping. These are different bootstrapping methods. The stationary bootstrap, circular bootstrap, CBB, MBB, moving block bootstrap, and custom bootstrap, right? Optimal block length. And as I said, this is written by Kevin Shepard. He's a professor. Kevin Shepard, Arch. He's a professor and associate professor from University of Oxford. He's a big figure when it comes to financial econometrics. So I personally have learned a lot from him. So I encourage you to just follow his codes, look at the GitHub repository, and learn from him. All right, so that was where you can do it from scratch on your own. But then basically you have to literally do it from scratch. So for example, you have to generate 100 different, let me actually give you a little more details, maybe you're interested. You have to, let's say, where's the Arch documentation? Well, actually, bootstrapping examples, maybe. Yeah, you have to generate, let's say, the 100, 200 paths for your bootstrap, and then you have to construct a decision tree based on each path of bootstrap, and then use ensembling methods in PyCaret to put those 1000 paths of bootstrap that you were generating by, let's say, moving block bootstrap. Okay, so you don't have access to all these models, but you can definitely construct them from scratch. Okay, all right. So I'm gonna say, let's just, for the sake of argument, let's work with these ones. You know, the more famous ones that we all know. Naive forecaster, Mosspeeder. This is your benchmark, the random walk. ETS, Arima, Random Forest, KNN. KNN usually does a decent job when it comes to capturing nonlinearity, especially if the dimension of the data is low. So KNN, I like to have it in my arsenals. And then XGBoost, LightGBM, CatBoost, so these are the more advanced ones, and we can do gradient boosting regression. So if you even run this one, again, so this is still in the train set, right? So, and looking at the performance in the holdout set, so these numbers are going to be exactly the same as this, so nothing new here. But the reason that I do it this way, because you can run a for loop, go through the list of these models, and then tune them, and see how the tuned one perform. So I'm going to create them individually though, because I want to see the output after creating each model. So I'm going to say, let's go ahead and create ETS. This is the ETS one. And again, the number that I'm going to get for ETS is going to be exactly the same as this, minus 2.16 for R-square, for example. Okay, this is, and remember, we did 9-fold here. And this is a tuned version of ETS. And let me actually do this one as well, even though it's going to take a little long. But again, so for example, for ETS, how can you change the details of ETS, right? So you have to go to the sktime documentation and play around with that, right? So let's go, for example, here, let's go to the forecasters, search for ETS. Let me actually find it here. Oops. Yeah, my computer is, okay. So let's do ETS. And then, yeah, these are exponential smoothing based forecasters. Then, oops, sorry. So we can do auto ETS. These are the parameters. We can add error, trend, if you want to do damp trend, and etc., right? So you can simply in PyCaret change them. So for example, ETS, you can say, you know what, add trend is equal to additive, something like that, right? So this is something you can do if you wish. And let me go ahead and run it, see, yeah, we don't get an error. So simply copying the parameters from here and read the documentation. Again, the goal is to make sure you understand how to navigate between the documentations. Okay, so I'm gonna put it back. So the tuned version is doing a little better, maybe slightly better. So it's not, there's not much to tune in the ETS anyhow. So that was the ETS. We can do the same thing for Arima, tuned Arima, and we can do the same thing for our machine learning models, right? So in machine learning, however, be careful. This is, the story here is different compared to classical time series, right? Models. In machine learning, remember, we do this. We have to prepare the data, and PyCaret does it automatically by specifying that window, right? So by default, it's 10. I'm going to use the 10, the default one, but you can go ahead and change the window length to anything. So literally, you can say window length is equal to 20 and run it, right? So let's go ahead and see that. So this is window length 20, and I can use the default one, which is 10. And in order to make sure that the default is 10, we can go ahead and remove that. So this is, let's say SMAP is 0.049. If I remove this, I should get the same number, or you can keep track of the R-square. Okay, so okay, this this is interesting. The default should be 10. I know, but the number's close enough. Yeah, you dig deeper if you want, but this window length, yeah, the default value, we checked the documentation together, I guess, right? It was 10. But anyways, you just take a closer look. And we can tune this XGBoost. The tuned version is performing a little better, but for some metrics, right? But there's not a huge change. And again, this is a stock price, right? If it was any other well-behaved time series, it was a lot more promising. I'm not trying to disappoint you at this point, but this is the reality when it comes to stock price prediction. As I said, the stock return prediction is more hopeful, at least with classical regression models and machine learning. But the problem with that is you don't know the size of the bet, right? You only know the sign of the bet, buy or sell, but how much? That's a bigger problem. The KNN, the same story, tune KNN. Let's say we want to work with, our preferred method is tune ETS. We can look at the parameters of it. We are doing seasonality period, which was detected 5. And because basically there's 5 trading days within a week. So that's what we are seeing. And trend is multiplicative. We can look at the diagnostic plot. Now, so basically this is your residual plot, right? The more this looks similar to the white noise, the better. So this is not quite there. We can do stat check on the residual and see if they're white noise, if they're stationary, and etc. But again, that's a separate topic. And then we can look at the normality of the residual plot, periodogram. Again, if it was purely white noise, you expect to see a flat thing here, and it's quite normal actually. And then these are the residuals. There is no significant lag for ACF, PACF, which is not bad. And then you can change the size of these things as well. You can change the height and width by passing the quark data. I encourage you to read the documentation from PyCaret. So now we can make some predictions for in-sample. So these are the in-sample predictions. It's going to take a little long. I can zoom in. So this, as you can see, just like any other traditional classical time series models, it seems that in sample you are at the first look you're overwhelmed. Okay, this is doing perfect, but remember this is always one time period shifted. So if you calculate the performance even in the sample, again, in sample is going to be good, but out of sample it's not going to be good at all. I can actually look at, for example, out-of-sample predictions for one of our machine learning models. So let's create it first because I'm rerunning it. I need to make sure that we have created. Let's say XGBoost. So let's create XGBoost. Okay, now I have XGBoost. I can change it back down there. So I'm going to go ahead and make prediction using tuned ETS. Okay, this is what ETS is predicting. Again, holdout period, that's why you get a negative R-squared because the average is going to be better. If I simply do the average is better. And we can make predictions into the future. You know, this is multi-step ahead, right? We're doing multi-step predictions, but that's pretty common, right? You could have done one step ahead prediction, but there's no point of doing that because you would rather to wait one day, look at the real observations and make a prediction for tomorrow. So maybe if you want to keep track or backtesting your strategy, you can do one step ahead and using historical data. So that's something. By the way, that's not built in PyCaret. So you have to do it. You have to run this entire thing, create a new setup, create model, and etc., and put it in a for loop, and then do it with PyCaret, which is computationally expensive. I would rather to do it with stats model, maybe like Python package instead of PyCaret. I wanted to show you the XGBoost as well. So for example, for XGBoost, this is how the XGBoost is making prediction for the last month, right? And even going into the future. All right, so that was it. Once we can look at the numbers, right? So if I do predict model using the, let's say, tune ETS, it's going to give me the numbers for holdout period, which is, again, we look at the plot, and we saw that why this has a negative R-squared, because it's doing even worse than a simple average here, right? So that's where the negative R-square is coming from. And these are your predictions, right? So we are, what is it? We are mid through February, and then these are the predictions. You can check if the model is accurate or not, but we know that the answer is no. Once you're happy with that, you can go ahead and finalize the model. So hopefully you know what is the finalizing thing in PyCaret mean, but for those who are new to PyCaret, the idea is that we're gonna go ahead, so this is what the finalize do. So far, we use this amount of data, right? We call it train set, to make a prediction in a holdout set. What was the holdout set? This was the holdout set. The last 22 days, right? Now, when we want to finalize the model, we are going to use the entire data set, including the holdout set. So basically, extracting every single information that we have as of today, right? So this is called finalizing the model. And so I'm going to finalize the model, which I think I did. And then based on the finalized model, we can make forecast, multiple step ahead forecast for the next 24 days. That's why you don't see that overlap with the holdout period anymore, because we are exploiting the holdout period as well. And then these are the predictions. All right. So this is quite common, in stock price prediction. No matter what model you do, usually they're kind of flat, or they're upward sloping, downward sloping a little. And as you go further into the horizon, it gets worse. So it's quite normal, and that's the nature of it. We can look at those numbers as well. So we can call it unseen predictions. So for example, this is the first day of January through 13th day of January. All right, that was it. So that was us trying to predict stock market price using PyCaret. So my final message to you is invest in yourself, because this is one of the most valuable investment you can make. As I mentioned, learn data science, machine learning, deep learning, and AI in general. This is a great way to make an investment in yourself. These are highly in-demand skills that you will likely only become more valuable as the technology continues to advance. And just remember, this is a long-term perspective, and you should not get involved this is my opinion, okay? So take it with a grain of salt. You should not get involved in the short-term, quick profits from, for example, day trading. It is essential to remember that building these skills and knowledge takes some time and dedication. So my advice to you is just be patient and persistent in your